recording. So this is 2:10:15, and we're going to start off just talking about what a chemical reaction is. Oh, wait! We forgot to do something. No, we forgot to do your what do you know. So let's go look at what you know and talk. Okay, so having looked at what you do know, which is a lot of stuff, let's talk a little bit about what chemical reactions are. It's the process by which one or more substances are changed. We get new substances out of a chemical reaction. And two important terms, I didn't see anybody mention this in the what do you know. Reactants and products. Okay, I missed it then. So reactants are what goes in, products are what comes out. The reactants are what react. And when we write a chemical equation, if we have A plus B equals AB, these are our reactants, and this is our product. Okay? Pretty straightforward, and you probably all did already know that, I think, from physical science. Importantly, the total mass of the reactants has to be the same as the mass of the products. So if you have 100 grams of stuff going in, you're going to come out with 100 grams of stuff, always. Many years ago, I took a really large, really intimidating chemistry exam. It's chemistry praxis, and it's a 2-hour, no kind of fun whatsoever chemistry test. I passed it, but there were also no calculators allowed, and they had stoichiometry. And there was one, and it was, you know, I'm sitting there and I'm doing what many of you do. Oh, okay, and what else? And I can't. Duh. Mass of the product is the same as, you know, it was what would be the mass produced of blah 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 and blah blah blah. Well, the answer was the same as the mass of the reactants. Duh. Which is why they gave it to you on a test with no calculators. So mass to start with is always the mass to end with. You can't create or destroy mass. You can't make mass magically appear, and you also can't poof disappear it into a black hole someplace. Even then it doesn't disappear. Okay, what's a chemical? Do I need to slow down so people can write? Or are you all just going to go print them out and... Okay, good. Whoops. So, a chemical equation is not the same as a chemical reaction, but it's how we describe a chemical reaction. So, what we see in a chemical equation are symbols and numbers that represent how much of each substance goes in and comes out. So we have symbols and formulas with the identity, the state, and the relative amounts of the reactants and products. You probably have not seen state symbols yet. We don't really do that in physical science. And so that's these little tiny things down here that tell you what state things are in. So that chemical equation there can be read like a sentence. And what it says is that solid ammonium dichromate reacts to form gaseous nitrogen, solid chromium-3 oxide, and gaseous water. And if we want to read it with more detail, we can say 1 mole of solid ammonium chromate reacts to form 1 mole of gaseous nitrogen, 1 mole of solid chromium-3 oxide, and 4 moles of gaseous water. So that's all contained in that equation. And you're going to, by the time that, so I forgot to put up the learning goals yet. By the time this week is over, or certainly by the beginning of next week, you'll be able to take a sentence like this, and you'll be able to write that equation. You can do it. You'll be able to anyway. You can do it. You can absolutely do it. Okay. So, I think most of you actually know this already, so we're going to spend short time on it. How do you know a chemical reaction occurred? Well, first one is heat or light. That would also be the kaboom, is often the evolution of heat or light. Production of a gas. How do you know that something is producing a gas? Bubbles. Tiny bubbles. Yeah. In my beaker. So when you have a gas that suddenly develops inside a liquid, that gas comes out in the form of bubbles. So when something starts to bubble, a reaction has occurred. A reaction is occurring. Formation of a precipitate. So here we'll do tiny bubbles there. I was thinking bubbles the chimp. Remember, if you're not part of the solution, you are the precipitate. So the precipitate is when we've got this lovely clear solution and suddenly we have chunks. And you guys saw this in your last lab where some things form precipitates. So when you form a precipitate, what that means is a chemical reaction's occurred because you went from having a bunch of stuff that was all soluble to suddenly having some new thing that was not soluble. And that's your precipitate. And the other one is, of course, color change. So when things change color, you're creating a new substance that has a new color. And you, again, saw that in the last lab. The last lab was actually great for indications of a chemical reaction because you got to see a lot of those things. Now, we didn't have anything that heated up. Like I said, we will have some things this time that heat up pretty nicely. So they evolve heat. We don't have anything that goes kaboom, but we'll talk a lot about things that go kaboom. Characteristics of a chemical equation. Any chemical equation has to represent known facts. So when I say known facts, part of that also means, do all equations run? No. So you can't represent, I mean, I can say that I mix gaseous. Okay, we'll pick it up tomorrow because the bell's going to ring in a second. So that's it. We'll pick it up tomorrow.